A definite integral is written with upper and lower limits attached to an integration expression such as the following. The integral of f of x from a to b is how we pronounce that. The value of a definite integral may be thought of as signed area from the lower limit a, usually a left-hand boundary, to the upper limit b, usually a right-side boundary, and between the curve of f of x and the x-axis. If that area is bounded above the x-axis, we consider that positive area, but if it's bounded below, that would be considered negative area. Notice how this means the value of your integral, your definite integral, could be positive, negative, or 0, but it will always be a number. Notice the second function has equal area above and equal area below, so the integral of this line shown in the second graph from a to b would be 0. For calculator integration, a TI-84 can evaluate a definite integral from a to b in two ways. You can use the calculate menu after putting f of x as y1, and this shows a graphical representation of the signed area together with the value, with the answer for the definite integral. Or if you don't need the visual, you can just go straight to function integral in the math menu. To begin, we're going to use the calculate menu to evaluate. First, go to y equals and type in x cubed minus 6x. Then click second trace, which gives you a menu for calculating. You're going to click the button 7 or scroll down to the 7th option and click enter, which is giving you the option to integrate. Then you can move your cursor to give a lower limit and an upper limit, or you can just type it in. So type in -3 and press enter. Type in 1 and press enter. And then enter one more time. Here is the area indicated between -3 and 1 and our curve in the x-axis. To see a better picture of that, here's your area visualization, and the answer for this integral from -3 to 1 is 4. Number 2, let's try it again. Same function, same process, just different limits. So choose second trace to calculate the integral. Give the lower limit as -√6 and the upper limit as √6. Press enter in between each time, and you should get your integral. And the answer here is 0. All right, here is a bigger visualization of what our signed area or bounded region looks like. This function is the absolute value of the function we had before, so we're going to need to go back to y equals and type it in with absolute value. How do you get to absolute value? Well, we choose the math button, click the right arrow to move to the heading NUM, which stands for number, and the very first option is abs, which is your absolute value. Select that option and then type in your function. Let's take a look at the graph. Here it is, and now we're going to integrate from -5 to 5. Second trace, choose the 7th option, type in -5 and enter for your lower limit, type in 5 and enter for your upper limit, and enter one more time to get your integral. The answer for this area is 198.50115. The exact same problem we did before, we're going to do again, but this time we're going to use the function integrate option in the math menu. So the first step would be to click math, and then the 9th option is function integrate. For a TI-84, it will have math print, which looks just like this. You'll know where to put the -5, where to put the 5, where to put the function, fill in the x for the dx, because you'll see it in this exact format because that's called math print. It has printed it in the math format. But if you have a TI-83 or an older TI-84, it will not show you this integral, and the order in which you will need to type each thing is to select function integrate, type in the function or refer to it using y1 or y2 or whatever variable you put it as, comma, x, because that is the variable with respect to which you are integrating, comma, lower limit, comma, upper limit, enter. And that should give you the integral. And your final answer was 198.500. Basically the same answer. If this were ever on an AP, I'm sure they would just give you the credit. There are sometimes minor rounding errors, or sometimes there are minor errors. The calculator obviously tries to be as precise and as exact as it can. Function integral in the math menu can sometimes give us a slightly more precise answer, but if this were an issue on AP, they would accept both the answer we got for function integral or if we used the calculate menu. And that is definite integrals and using a calculator for definite integration. Use the idea of signed area to evaluate the integral of absolute value 2x minus 1 from 0 to 3 without a calculator. This is an absolute value graph that it just has one vertex or one sharp turn. So I'm going to graph and then use geometry to find the areas. I would like it to be in graphing form, so I'm going to make sure that x has a coefficient of 1 by factoring out 2. The absolute value of a product is the absolute value of each piece of that product separately, so 2 times absolute value x minus 1/2. The vertex for an absolute value is at h comma k, so our vertex is at 1/2, 0. And the slopes of the lines that make up the v will be -2 and +2. Up 2 over 1, up 2 to the left 1. We are evaluating from a is 0 and b is 3. So our lower boundary is 0 and our upper boundary is 3. Integrals are talking about the area between the curve or the function and the x-axis. And signed area is just talking about if the area is above the x-axis, it will be positive, and if that area is below, then that will be counted as a negative. So it looks like all of the area they want us to find here is positive. So the integral from 0 to 3 of absolute value 2x minus 1 can be rewritten as two separate integrals. From 0 to 1/2, we have this little triangle, plus the section from 1/2 to 3 is a much larger triangle. And so for these integrals, I'm not actually going to come up with some rule for integrating absolute value. I'm actually going to interpret integral as signed area and find the areas. I do know how to find the area of a triangle, 1/2 base times height. So for this smaller triangle, my base is 1/2 and the height is 1. For my much bigger triangle, the base is 2.5, so 5/2, and the height is, when x is 3, what is our y value? That would be 5. (13/2), meaning the areas between the curve and the x-axis. Set up a definite integral which could be used to find the area of the region bounded by the graph of y equals 2x squared minus 3x plus 2, the x-axis, and the vertical lines x equals 0 and x equals 2. To find the area of this region between the curve and the x-axis, so integral of this curve, and we're finding a specific area, so from the lower boundary to the upper boundary. Lower boundary A is 0, our upper boundary B is 2. This integral would give us this area. But they didn't ask us to solve it, so we're done.